केमिकल बॉन्डिंग। बॉन्डिंग दोस्ती है, ए बॉन्ड एक फोर्स ऑफ अट्रैक्शन है दैट होल्ड द एटम्स टुगेदर इन ए मॉलिक्यूल। तो जब कभी भी हमें बेटे नई दोस्ती बनानी होती है तो हमें पुरानी दोस्ती तोड़नी पड़ती है। तो जब तक नई दोस्ती अच्छी नहीं होगी तब तक हम उसको नहीं बनाते। उसीलिए बॉन्ड जो नया बनने जा रहा है, द न्यू बॉन्ड विच इज बीइंग फॉर्म्ड, दैट मस्ट बी स्ट्रॉन्गर देन द ओल्ड बॉन्ड। एनर्जी इज रिलीज्ड when a bond is formed and energy is required to break the bond. Why do the atoms combine? The atoms combine in order to have the stable configuration of the nearest noble gas, which we have seen in our previous classes that noble gases do not form compounds. It means the atoms combine to have complete octet. How can they attain this octet? Either by the transference of electrons or by the sharing of electrons. You know, transference of electron results in the formation of ions, hence the bond is ionic bond. Now, in the case of ionic bond, one of the atom must lose electron, other must gain. So one must have low ionization energy, other must have high electron gain enthalpy. This is in the gaseous state, and ionic compounds are solid, so lattice energy is released. In nutshell, we can say an ionic bond will be formed only when lattice energy plus electron gain enthalpy is greater than ionization energy. It means that for the formation of ionic bond, energy has to be released. Now, supposing you get a question, which of the following combination will have strongest ionic bond? So what you have to see is that the ion cation which is being formed should have low ionization energy. The anion which is being formed should have high electron gain enthalpy, and thirdly the lattice energy should be high. Now if we see these examples, you will see that magnesium has got 2 positive charge, oxide has got 2 negative charge, so the electrostatic force of attraction will be more, so the lattice energy will be more, hence the best choice will be the 4th. Now ionic compounds do have covalent character also, which is explained on the Fazan's rule. According to it, greater the polarizing power of the cation and greater the tendency of the anion to get polarized, greater will be the covalent character. Polarizing power of the cation depends upon size of the cation. Smaller the cation, greater the polarizing power. Charge, greater the charge, greater the polarizing power. And if the cation has pseudo-noble gas configuration, means 18 electron in the outermost orbit, it will have greater covalent character. That is why, dear students, you find that the compounds of transition elements do have covalent character, and those who have covalent character are soluble to some extent in alcohol or ether. Let us take another example. Which of the following is correct regarding covalent character of the ionic bond? I have told you, first of all, you have to see if the cation is same, then the anion. The anion must be large in size, it must have greater charge. In the first example, in the first choice, lithium fluoride, lithium chloride. Lithium chloride has greater covalent character. Cation is same. Now regarding anion, chloride should be larger in size. So this is wrong. Second choice, sodium chloride, lithium chloride. If the anion is same, then look for the cation. Smaller the cation, greater the covalent character. Once again, lithium chloride should have greater covalent character than sodium chloride. Now the third choice, cation is same, anion is same, then they have got different oxidation state. I have told you, greater the positive charge, greater the covalent character. In this case, ferric and ferrous are there. So ferric has greater positive charge, hence ferric chloride will have greater covalent character as compared to ferrous chloride. Now again look at the fourth choice also, just to clear your concept. You see, now the cation is same, sodium and iodide. Then look for the iodide is same. Look for the size of the cation. Smaller the cation, it means lithium iodide should have greater covalent character than sodium iodide. It means fourth choice is wrong. You can solve the question in this manner also, but these 3 choices cannot be the answer, so the answer is third. Because you might not have come across pseudo-noble gas configuration, but now I have told you a pseudo-noble gas configuration means to have 18 electron in the outermost orbit. In this context, he can ask you, which of the following compound will be soluble in acetone out of sodium chloride, sodium